Welcome to the Middleware Tech YouTube channel. In this series, you'll learn distributed environment communication. All code examples used in the videos will be available on GitHub. Let's get started.
Now, what is the meaning of this? Is the term that is, when talked about Java, when you're learning Java first time, you may have heard these terms. Distributed. Java is called distributed, right? So this is the first page of Java books or Java technical materials. You'll find that Java is called distributed. What does it mean by this? Distributed means all function JVM to another JVM. Let me tell you, JVM means our virtual machine. It is used to run your Java code, right? So distributed means is this. In a single line, if I want to say the meaning of distributed, then I'll say that calling a function from one JVM to another JVM. This is a single line answer of distributed. So what does it mean by this, right? So let me give one example. Assume this is my server 1, and when you have server means either WebLogic or JBoss or IBM WebSphere, whatever it is. This is my server. So when assume this is Air India website is running inside this server. Assume. So this is using one JVM. JVM means here in this server one JVM installed, right? And Air India, and I can buy the ticket from Bangalore to Hyderabad or Bangalore to Delhi. So I can use the Air India website to buy the ticket from there, right? Okay. Now I have another application called Indigo. Applications are running inside another server. Let's say server 2. Assume this is another server, and this is using another JVM, Java Virtual Machine. Application is running inside another JVM in this server, right? So and we have another application like GoIVivo or MMT, like my trip, right? So MMT is another server is there. So assume they have their own server 3, right? And this is also running inside another JVM, right? Okay. Now, as you know, we can go to the Air India server, we can go to the Indigo server, but without going there, we generally go to Make My Trip, like applications like ClearTrip, like GoIVivo, this type of applications. Why? Because this there will get all the flight details in the same location, right? Okay. Why? Because this server and this server is going to exchange based on the vendor agreement. After 1 minute, the flight details of Air India server is upgraded inside the MMT server. Based on the agreement, after 1 minute or 1.5 minute, flight details of Indigo or Airlines applications gets upgraded inside this server of Make My Trip. So here what happened is that one server is going to call another server. Why? Because Make My Trip need to update the details about the flight in their application, Air India, Air Asia, or some other server applications, right? So automatically these two servers is going to exchange some information during runtime. It's going on, right? So what happened? This server is running inside one JVM. This server is also running inside another JVM. So the code in this server is running, the code that is available inside this JVM is going to call the code that is running inside another JVM. the code that is running inside this JVM is going to call the code that is running inside another JVM. So whenever you find the scenario where any code is going to call the code that is running inside another server, that is called distributed. Distributed means remotely calling some functionality. What does it mean by remotely? We generally use, you may get the term called remotely call some functionality. Distributed means remotely call some function or some procedure. You may get RPC, you will get another term called RPC, remote procedural call, RPC, remote procedure call. That means remotely calling some function. So remotely calling some function means what? Calling some function from one JVM to another JVM. This is the, from Java-based point of view, this is how we define the concept of distributed. Fine, fine. So we say Java is distributed. We say Java is distributed. So, right. So this is the idea behind distributed technical term. What is the meaning of distributed? That is the idea, right? Okay. Now, what I'm saying here, I'm talking about distributed communication. Distributed environment communication. I'm talking about distributed environment communication. So distributed term is clear. Now, how we'll implement distributed environment application? How we'll implement distributed environment communication level application? I'm talking about distributed environment communication. I'll come with all the slides. Let me spend some time on Notepad, then I'll come with the slide. So distributed environment communication, if I want to distributed environment communication, so let me take this example itself. Okay, distributed environment communication. Let's understand using some example, then it will be very helpful. So how we can implement distributed environment communication? To implement distributed environment communication, first technology came. First, that came RMI. RMI full name is remote method invocation. RMI full name is this, remote method invocation. First time this RMI came, okay, to implement distributed environment communication. So how this distributed environment communication work, right? Okay. Okay. So assume this is my server 1 and this is my server 2. Right? Okay. Now in this server, I have a Java-based application component like EJB or Java-based application component. Fine. And here I have another server and I have .NET based application component, right? And here I have another server 3. Here I have C++ or PHP based application component, right? Now I'm talking about distributed environment communication. So distributed environment communication, first we implement with the help of Java. So we can say first point, RMI, it is used to implement distributed environment communication Java. That means If I have a Java application component in the server 1, if I have another Java application here, I have a Java-based application component in server 2, assume. So in that case, I can implement the distributed environment communication between them. So using RMI, I can implement distributed environment communication. The condition is both the server must have Java-based application component, right? So using RMI, we can implement distributed environment communication, but it is homogeneous. Homogeneous means Java-based application component that is running inside server 1 in one JVM this is running in one JVM, and this is running another JVM, right? Fine, right? So homogeneous means one server code is going to call to another server code, and both are Java based. RMI, using RMI, we can implement distributed environment communication, but in that case, both the server or both the JVM, they must have homogeneous component, means Java based components. EJB to ADFBC, ADFBC, so right, Java based component. Fine. So the question is, how does distributed environment communication work? So I have not copied anything. If you want to see how distributed environment communication work, some are implemented between two servers, and the communication is between the communication of stub and skeleton. Now, what is this stub? It's a Java object. What is the skeleton? It's a Java object. So this stub, now, why it is saying stub? Stub and skeleton, these are a special kind of Java object. Why special kind of Java object? Because this object can handle some low-level communication with network. When I'm talking about that, the distributed environment communication will implement with the help of this stub and skeleton. The stub will be in the left side, machine A. This is called the producer, or whatever it is. This is, assume this is a requester, and this is a provider. So one is requester system, another is a provider system, right? So how they'll communicate in distributed environment communication? Distributed environment communication always implement using a distributed object. That object name is stub and skeleton. Fine. Okay. So this stub object will create in the client side. Assume this is my client and this is a server, or one machine can be a client to another machine. Assume this is Magmatrix server and this is an Air India server. So one server can be client to another server in distributed environment communication, and they'll communicate using an object called stub and skeleton. Fine. So this is stub, as I told you, that it's a Java object. Fine. It's a special kind of Java object that can handle low-level communication and distributed environment communication. Skeleton, this is also one type of special kind of Java object that can handle low-level communication and distributed environment communication. So why I'm saying a special kind of, say, when you're going to call a particular function from machine A to machine B, when I'm going to call a particular function from machine A to machine B, I'm going to call from one JVM to another JVM. That means what? I'm going to send some stub object from this system to this system. So this stub object that I'm going to send from this machine A, before sending, this is stub object. That is stub object contains lots of details. This stub object is going to call a particular function in which server IP. What is the function name? What is the input parameter? Right. So what is the location of the function? So all the details we have to marshal inside the stub object. Then I have to send it through the network. So that process is called marshaling. Before you are going to send a stub object through network to the destination server, so I have to marshal all the input parameter that I have to pass to the destination server inside my stub object. That process is called marshaling. I have to implement marshaling, and using marshaling, I have to send this object through network to the destination server. Fine. So in the destination server, when stub came here, what will happen? Whatever the details is available inside this stub, that it will unmarshal. The object that you have marshaled inside, the input parameter that you have marshaled inside a stub, when it will come to the destination server, it will unmarshal all the details. And when you unmarshal all the details, then a skeleton that will not go through the network before Java 1.5 version. That will not go to the network. A skeleton will always exist inside the server. So when the details came through a stub inside the destination server, it will unmarshal all the details, and a skeleton is going to call the specific function in the server side, right? And it will get the output, and that output once again marshaled inside an object and send it through network to the client server system, right? So in distributed environment, communication is always a communication between a stub and a skeleton. They will communicate, and in distributed environment communication, right? So that we can implement using RMI. So the example that I have given here, I'm talking distributed environment communication. These two server, distributed environment communication between these two server, we can implement using RMI. RMI, what I am going to do, how to create a stub, how to create a skeleton, how stub is going to call the skeleton, right? So there is a separate RMI programming is there. We can implement complete communication using RMI, right? So it is homogeneous. Hence only Java code inside Java code can call a Java code inside another server. Only Java code in one server can call Java code inside another server, right? Homogeneous. So RMI was successful to implement distributed environment communication, no problem. But the problem with RMI is it is homogeneous. But see, today's environment, we are going to interact with different applications, and different applications are means built with different vendor application component. So today's environment, if I'm going to interact with enterprise level application, it is not that it is always Java based. No, right? So we need an application component that will work or that will communicate in heterogeneous environment. That will communicate in heterogeneous environment, right? So to resolve this problem, second application component came. Its name is CodeBA. Full name is Common Object Request Broker. Check the spelling, I think. So this is called CodeBA, Common Object Request Broker Architecture. So this CodeBA, second component, second application component that came in the market to implement distributed environment communication. So we can write one point. I'm just saying the headlines, Control C. So it is used to implement a heterogeneous distributed environment communication. Fine. So that means what? That means if I'm going to copy paste this line here, that means Control V. I'm talking about code one now. So here I can use this server Cordova. Fine. Okay. So assume in server one I have Java-based application component. Assume, and the name of the Java-based application component is ADFBC. Fine. Okay. And in the server two, I have .NET-based application component. Right, in the server 2 I have .NET-based application component, and the application component name is DCOM. Right, so what type of communication it is? It's an heterogeneous communication. Heterogeneous communication. Why? Because this server, assume this is an Air India server and this is an MMT server. So these two servers is going to communicate with each other. And this is Java-based application component, and this is a .NET-based application component, right? And these are two different vendor application component. That's why I say it's a heterogeneous environment communication. So RMI was not successful to implement heterogeneous environment communication. We cannot implement it using RMI. To resolve this problem, this Cordova came, right? So using Cordova, we can implement heterogeneous environment communication. So how Cordova will implement heterogeneous environment communication? What Cordova do? Cordova use one concept. That is called ideal. Cordova use one concept that is called IDL. Ideal full name is Interface Definition Language. IDL, Interface Definition Language. So how these two servers will communicate with each other using Cordova? Now here in the left side server, you'll find Java object. It's a Java, right? So Java object. So what you have to do, we have to create in the server one Java ideal for this Java object that will take care of the object in distributed environment communication. In the right side server, my application component is .NET. So I have to create .NET ideal for the .NET ideal, the application component that I'm using here, right? So and the Java object and .NET object, they are going to communicate between these two servers. Java object and .NET object, they are going to communicate between these two servers, right? So the Java object that are going to communicate with the .NET object, they both will use for Java object Java ideal, for .NET object .NET ideal, and they are going to communicate distributed environment communication. That is heterogeneous environment communication, and we'll implement with Cordova. This is how it will happen. If you are using PHP object, then PHP ideal you have to create for that particular object, and the ideal will take care of the object in distributed environment communication. Okay. Now using Cordova, we can implement distributed environment communication. It was fine. Now, what is the problem with Cordova? It support, second point we can write, it support heterogeneous environment communication. It support heterogeneous environment communication. Now, what is the problem? Problem with Cordova is that the complexity is high complex. First point. Second point is that implementation cost is high. Implementation cost is high. That is the problem with Cordova. Okay, so that's why enterprise level application they'll not go with Kodwa. Right. So what is the solution? So next solution came number 3, distributed environment communication. Next solution came, that is distributed environment communication XML web service. XML web service. So this is also used to implement distributed environment communication. So next solution came XML web service. So first, if you see a distributed environment communication, we can implement using RMI. Has some problems. It will support only homogeneous. So I came with Kodwa. That is also have some problem. It supports heterogeneous, but implementation cost is high and highly complex. Based on that, came to the solution XML web service. So using XML web service also you can implement distributed environment communication. So XML web service, we can implement distributed environment communication, right? So now the question is that how we can implement distributed environment communication using XML and web service, right? So let me use the same example. No? Same example. This is an example just now I've written. How we can use Control C distributed environment communication using XML and web service, right? So I'm just discussing all the things. So I'm not coming. I'll come with PPT all the things one by one. So I'm talking about XML web service communication. XML web service distributed environment communication. That I'm talking about. XML web service distributed environment communication. Right? How we can implement? Right? Okay. So assume, same examples I have taken, same examples. Assume in this server they are using one of the application Java-based application component. Assume it is EJB. Fine. Okay. And Indigo server, this is running inside server 2, right? And assume they are using one of the application component that is .NET COM-DCOM. Okay. Assume application component COM-DCOM. Assume. Fine. And we have make my trip server that is running in server 3, and assume they are using one of the application component Spring BC. Right? Okay. So now this is a communication between in heterogeneous environment communication Java to .NET, right? So how we'll implement XML web service communication, distributed communication in this, right? So what we'll do here is that so see, this is Java object, this is .NET object, and this is Java object. So what we are going to do here is that whatever object details available inside Java object, we'll extract those details inside an XML or JSON file. Fine. Now, whatever the details available inside .NET object, those details will extract inside XML or JSON file. Whatever the details available inside this Spring BC Java object, that will extract inside XML or JSON file. Right? Now this is Java, this is .NET, this is Java. So what I'm going to do, whatever details available inside this object that I'm taking inside XML and JSON, this is vendor independent component. Right? So this is a vendor independent component. XML and JSON is a standard. Anyone can use XML and JSON according to W3C consortium. So you don't have to take any license from any vendor. So now this is a standard of communication. Now these servers are communicating using this standard. So all the objects details is coming inside this vendor independent component. and they are going to communicate using web service, right? So this is happened in XML and web service communication. Your Java object or .NET object details you'll put inside XML or JSON, and that is going to communicate using web service, right? And this is how they have resolved or they have implemented XML and web service communication. And we have to know how it will work, right? How web service communication work. So using XML and web service, we can implement distributed environment communication. This is how. This is the example. I'm just saying layman's language just to understand the idea. Okay. So, but these also have some problem. Control C. This is also have some limitation. You can implement distributed environment communication using this. This is also have some limitation. Limitation is that these servers will communicate and using an vendor independent standard of communication, right? But there is no centralized control. You'll not get a centralized control. This server is going to call this server is going to call this server, fine, using a web service, but there is no centralized control. Okay, so to get centralized control, another component came. You may have heard the name called SOA, service oriented architecture, right? So different vendor came with their SOA, IBM SOA, Oracle SOA, then Apache SOA, Microsoft Dynamics is Microsoft SOA. So different vendor came with their SOA. What is the purpose? I'm writing a single line. Lots of points is there. To get a centralized control in this web service communication, different vendor came with their own SOA. Fine. This is one type of scenario. Now today's environment, today things got changed. Now, if I'm going for this type of scenario, I'm saying today's scenario. Today is not the scenario how we are talking about. This is okay. We are moving like this way, it's fine, no issues. So that means what? If you want an project, if you want to execute that project, you have to take one server. Developers will create the web service, and those web service is going to communicate with another service. Right. So this is how the communication will work for a particular project. But today's environment, things are changed in the sense what will happen over next 10 years. Next 10 years, all the things they are going to use one infrastructure called cloud infrastructure. All communication they want to implement in cloud infrastructure. That's why different vendor came with their different cloud. Amazon came with Amazon AWS. Microsoft came with Microsoft Azure. Google Apps. So now today things are, all the organization, they are moving to the cloud environment, and to reduce the cost of handling a particular project. So right, so to handle a particular project, you need admin, you need server, you need developers who is going to create, and you need an infrastructure to handle that particular server, right? So lots of things is there. So today's environment, distributed environment communication, they use the cloud environment. So all the organizations throughout the world, to reduce cost and to get high profit, most of the organizations, they're moving in the cloud environment, right? So this is how the things are going on. But before going there, we should know how web service work, right? And this is the technicalities we should know, right? Okay, leave it. So our topic is web service, right? So we are talking about XML web service distributed communication, how it will work. This is how it will work, right? Our topic is not SOA also. Okay, so this is the things, right? Okay.